Okay, so now we're going to get into talking about our parameters and how do we target the different areas of the effects that we've talked about for ultrasound. How do we get those to happen? So the first thing we're going to talk about is how do we get thermal effects. And so to get thermal effects, we want tissue heating. Research is really showing that anytime that spatial temporal average intensity gets greater than zero point 0.2 to zero point 0.3 watts per centimeter squared, thermal effects are happening. Okay, that's when the body no longer is able to dissipate the heat and will gradually get an increase of heat anytime we're above that 0.2. So whenever there's a thermal effect, remember that there's also the non-thermal effect. Um, so again, when you have to talk about the science behind things and the effects that you're trying to get, you're going to have to talk, if you're talking thermal ultrasound, about the thermal effects, the benefits of the increased blood flow and the increased viscosity and the increased cellular metabolism, as well as those non-thermal effects. So the cavitation, the microstreaming, how those then affect the cell membranes, how those affect cellular activity, how they increase macrophage activity, all of those things. So all of that's happening every time the ultrasound unit is on. We get all of those non-thermal effects too. So the goal being, when we are setting up our ultrasound to try to get thermal effects, the goal that we're trying to reach is the fact that we want to raise that tissue temperature to the certain amount we want to get to. So back to our chart, we'll see it again in a minute, of that increase of 1 degree, 2 to 3 degrees, 3 to 4 degrees. We want to get up to that temp increase, and then we want to kind of stay there for about 3 to 5 minutes. Okay, so we're going to talk about how do we figure that out. And you also want to remember that we are heating, so the person should actually feel heating happening in the body. They might not feel it on the surface of the skin because again, we're penetrating deeper, but the area should eventually start to feel warm. So with that stretch window that we've talked about too, if we're trying to get to that vigorous heating, when we're trying to actually get the collagen to relax and to kind of loosen and to decrease the viscosity, we want to manipulate that stretch window. And so as the temperature is up in that 3 to 4 degree temperature increase, we want to be stretching while we're doing the ultrasound. And then we have about a 5-minute window where we can continue to gain stretching, either by what we would consider stretching or joint mobilizations or potentially traction. Okay, so how do we figure this out? This is where math comes in. And so this is the part that probably confuses the students enough, but you have to eventually memorize, the chart that I have up here. So remember back to our heating requirements. So baseline temperature is 36 to 37. That's not really important for you to know. What is important is that if we raise it 1 degree Celsius, we get that mild heating. If we raise it 2 to 3 degrees Celsius, we get that moderate heating. And if we raise it 3 to 4 degrees Celsius, we get that vigorous heating. And then the actual effects that we get from those different levels. And so depending on the goals for this treatment, okay, we got to think about our levels. So most often, a lot of our stuff is about reducing spasm, the pain, chronic inflammation, maybe increasing blood flow. That would be a lot of our reasons of why we're using thermal ultrasound. And for our goals. But we might be up here in this vigorous heating trying to decrease the viscoelastic properties of the collagen, get them to relax and be more stretchy. Very rarely are we just trying to accelerate the metabolic rate and decrease mild inflammation. So we're usually up in these two. But what we see over here then is that based on the intensity that we set, so our watts per centimeter squared, and based on our frequency, we will raise the degree, the temperature at a different level, okay? So it's roughly about 3 times faster to use 3 megahertz than it is 1 megahertz, but it's not exact. That's using 1.0 watt per centimeter squared. So if we were using a 0.5 watt per centimeter squared, and this is all for 100% continuous ultrasound as well, so no duty cycle set, okay, we'd get about a 0.04 degree increase per Celsius per minute at 1, or a 0.3 degrees Celsius per minute increase at 3. And so you can see those going up. So, if we were trying to target maybe deeper into the tissue, maybe somewhere in the quadricep, and we were using our 1 megahertz, that would determine our depth. And then we would want to set our intensity based on our goals, based on what our BNR says, right? Because we don't want a BNR that gets too high. So again, if our like BNR is a 6-to-1 ratio, somewhere in our beam, we would end up with peaks that are up near 12, right? So 6 times 2, 12 watts per centimeter squared, which could be potentially dangerous to the tissue. So we would maybe stay down here a little bit more. But otherwise, we're basing our treatment time based on what our goal is to reach our temperature, okay? So we use this chart and our temperature goal to determine how many minutes our treatment is, okay? So we're going to see an example here. So we choose our frequency based on our depth. So 1 megahertz or 3 megahertz. We pick our continuous duty cycle, so 100%, and then we choose our heating level. So again, are we trying to raise it only 1 degree, 2 to 3 degrees, or 3 to 4 degrees? Okay, with me so far. Then we got to decide on our intensity, and that could be due to the BNR. We might also end up adjusting this midway through if someone's saying, you know, that it feels too intense. Maybe we go lower and do a longer treatment. But most of the time, the only real thing that limits us is the BNR, and keeping that in mind. So then once we pick where we're going to go here, we've picked our depth and we've picked what intensity we want. So let's say we pick, in our example, we're going to talk about 1.5. Okay, so we pick this 1.5 watts per centimeter squared. Then we would then use the chart to figure out, okay, if I need to raise to a certain degree, right, 2 to 3 degrees Celsius, I would need a certain amount of time based on how much I increase per minute. Okay, so we use the chart to raise the temperature per minute, and we set our time based on how long we need to reach that heating level. Okay, the treatment should be temperature dependent and not time dependent. Too often when people get lazy with ultrasound, everything is 1.5 for 5 minutes at 3 megahertz or 1 megahertz, and they don't do the math to figure out what level of heating we really want to get to. You guys are going to do the math. You're going to be thinking about temperature dependency, not time dependency. Okay, so here's our example. We decide the level of heating and the temp increase needed. So let's say we have a old hematoma in the quad that isn't resolved. They have a lot of spasm around it. The tissue is kind of scarred up, so we maybe want to get that vigorous heating. So according to this chart over here, to get our vigorous heating, we need to raise the tissue temperature at least 3 degrees up to 4 degrees Celsius. Okay, so we see that over here. Then we're going to use our chart. So based on the fact that I said we're going to be, you know, in the quad with a hematoma, we would be thinking about our depth that we would want about a 1 megahertz. Okay, so in order to do 1 megahertz, and with our machine, we're going to say we have a like 5 BNR. Okay, so we can go potentially up to that 1.5 watts per centimeter squared. Okay, because that keeps us underneath our 8 watts per centimeter square limit of potentially dangerous. So we've picked our depth, we picked our watts per centimeter squared. So with that, we know we get an increase of 0.3 degrees Celsius per minute. So for every minute that we're on with our intensity setting and our frequency setting, we're going to raise the temperature in the muscle 0.3 degrees. Okay? So we need to get to 3 degrees Celsius of that increase, right? So vigorous heating for 1 megahertz, 1.5 watts per centimeter gets us our 0.3 degrees Celsius per minute. So if we need to get to 3 degrees of Celsius increase, and we're using 0.3 degrees Celsius per minute, okay, based on, you know, solving for X, in this case, we're trying to figure out our treatment time, we end up with 10 minutes. So it's going to take us 10 minutes to get to a 3 degree temperature increase. So 3 divided by 0.3 gets us 10 minutes. Now that just gets us up to 3 degrees. Remember, we want to say that we want to hold at that temperature for 3 to 5 minutes. So usually we'll lower our intensity a little bit, maybe go from 1.5 to maybe down to like 1.2, and continue our treatment another 3 to 5 minutes in order to try to keep the tissue at that 3-degree temperature increase. Now, since we could go up to potentially 4, we don't have to be as careful about turning it down as much. We could go a couple more minutes, 3 to 5 minutes, and potentially still be within our 3 to 4 degree range, just at our 1.5. But if we were up towards the upper border of that, based on our math, we'd want to potentially turn down the temp. So our total treatment time would be somewhere between 13 and 15 minutes. 10 minutes at 1.5 to get up to our 3-degree temperature increase, and then 3 to 5 minutes of holding at that temperature. So either just letting it increase a little bit more up to 4 at our 1.5, or dropping our intensity a little bit just to try to maintain that temperature. Okay? So again, if this is going to be the trickiest part of dealing with the heating. So I suggest come to class, ask me questions about this. We can throw some examples on the board, pull out the chart, and really start talking about doing this math. But we always take our degrees of increase that we're trying to get to, so our 3 degrees Celsius increase, and we divide it by how many degrees Celsius per minute based on our chart, okay? And then that gives us our treatment time. And then we add that 3 to 5 minutes at a lower intensity to try to maintain that temperature. So this just kind of in chart form from your book shows you how we get to that. So based on the different watts per centimeter squared, treatment temperature, this is our temperature increase. Okay, so how much we're raising temperature per minute based on our settings that we have. So we can see that the higher you set your intensity, the faster we increase temperature. But again, if you have a BNR, this could be a potentially, a high BNR, this could be a potentially dangerous, there could be some bad peaks in there. So we'd maybe want to stay away from that, or we'd really have to make sure that we're moving our ultrasound head a lot, or that we're really communicating to our patient. But in general, the higher you do the intensity, the shorter your treatment duration can then be based on the target of temperature increase that you want. And so this is at 1 megahertz. Over here we have 3 megahertz. And we can also see, comparing from 1 to 3, how much faster heating temperature we get as we use the 3 megahertz versus the 1. So, if we look at our 2.0, at 1 minute, we were barely under 1 degree Celsius increase with a 1 megahertz. When we're talking, or I should say at 2 minutes, when we're talking at 2 minutes with 3 megahertz, we're already above 2 degrees Celsius increase. So we dramatically increase our temperature faster. So our treatment times tend to be lower. But remember, the 3 megahertz and the 1 megahertz are all based on the depth of the tissue that you're trying to target.